Hello, everybody. Welcome. So, who am I? I'm Robert. I'm a data scientist. I'm passionate about helping game studios all around the world to grow their games. And today, basically, some of the knowledge that we gather in the SuperScale, we'd like to share with you. We had a chance to work on different genres of the game, so I feel like this could be really good to actually see from several perspectives how the data science can actually help to grow the game. So I was fortunate to really work on a project that analyze a lot of players. We are talking about really, really big data, talking about more than 500 million of players, optimized millions of dollars in media spend, and some of the projects that we had brought millions of dollars of extra revenue through data science. So today I would like to share these kind of like a knowledge and findings that we had and learnings and challenges that we faced. And of course, I'm really fortunate to work with SuperScale. SuperScale is game growth specialist. And as a game growth specialist, we are basically looking at increased profitability and scale the games to their maximum potential. So we really are not only working with the game, but also with the portfolio of the games. And our mission is to scale the games to the maximum potential. So how we use data science in SuperScale to grow games? So there are 3 points in this presentation I would like to touch on. One is how to understand the potential, and how to realize that potential of the data science based on a phase of the game in the life cycle of the game. Then how to build impactful solution. Impactful data solution means that we are acquiring right data, we are optimizing players' monetization experience in the right way, and we are putting it all together in a way that is really, really optimized, and we can do really, really interesting thing with that. And then what type of challenges we faced, and what were the learnings actually when we try this kind of stuff. So how to unlock growth through data science. So first of all, we have to talk about this lifecycle of the game, because data science has different relevancy based on a segment of the phase of the product. So starting with the pre-scaling game, going through growing game, where there's actually the game starts to scale, then established games where game already is peaked and already getting the much of the players and the revenue, and the legacy titles, these are already stable products, very long-term. So what about the data science? What is the role of data science in this lifecycle of the game? So really the relevancy increases as the product matures, because there's basically more data, you get more complex games, because as they develop, of course, there are many other game modes that are added, characters and so on. So as you have more data, you can really leverage it. So from the start, basically you can do something, but really it's really much limited on a scale. But then as you start to leverage data, start to getting data, you can leverage it through 3 basically things. We found out they are the most impactful. One is decrease the churn of the game. Second is increase the monetization. So change something through the data science in a game that actually the monetization can be improved quite significantly. And then support user acquisition. So really optimize the spending on the user acquisition. And this basically through the phase of established and the legacy, the data science basically has the most relevancy, but also already through the phase of growing, it's already something that data science can be used for. Now, when we check these phases, all these phases have the players that they play the game, right? So what we are actually encountering here is player lifecycle. We can optimize this player lifecycle through data science also, but of course, some of these points, some of the phases of player lifecycle have more relevancy in terms of data science. So at the start, user acquisition, activation, retention, monetization, and churn. So in terms of user acquisition, there is a paid and there is the organic. We can optimize the store, right? We can improve onboarding. We can improve the retention, improve the ad optimization or era optimization, and also, of course, decrease the churn through different means. But the idea is to understand where the data science is the strongest, where is the most impactful. So when we check this, we basically have user acquisition through different models of prediction and monetization, through different optimization based on the demand and supply of the game. Then we have a churn and retention. There's of retention, of course, how to actually retain players more effectively, data science. And in terms of churn, how to decrease the churn, how to find automatically and also decide automatically what to do with players that want to churn. But in this presentation, I'm going to focus on in-app optimization. I feel like this is most interesting stuff in general. We are going to reimagine game special offer system through data science techniques, which means that we are going to improve the monetization based on the data science techniques and different special offer systems. We are going to, but of course, through this optimization of monetization, we are going to also have some additional rules. For example, we are not going to increase the number of offers that the player sees. So we are not going to really spam with the offers. We are going to use only existing content, and we are going to use same or less discount than previously. So we can imagine having like an old system, and now we are going to create a new system of special offers. Special offer system, okay? With a new offer system, we are going to just improve in general monetization and using, of course, data science techniques. So based on our experience, based on the projects that I was part of, basically, as the complexity of the game increases, there are more opportunities to optimize player journey. So as the game is complex, so going from match 3, simulation racing, RPGs, basically you get more stuff to optimize because there are so many segments, different segments of the players that actually have their own journey. And through the data science, you can automatically understand this and improve your offerings, the special offers. So what does it mean is that as the game is more complex, you can expect that the potential of this kind of data science systems is better and is higher. What about user acquisition? Does it affect user acquisition? You will expect it, yes, because not only expect, we already seen it several times, right? So what we've seen is that as the LTV increases and CPI basically is stable, we get more opportunities to increase the spend, which means this basically improves our scaling capability. So again, the complexity of game, the potential from the data science is better if the game is complex. What about the profit realization? So now we know that something like this can work. Now, how this actually works in terms of time frame. So this is interesting, I think, because as we change the special offer system based on the data science, we can actually realize that uplift almost instantly. And now how instantly it is, it depends on risk, basically analysis. So as we know that we can scale faster, basically the realization uplift is going to be faster. But we don't have to wait like 2 years or 3 years to get the uplift. It's almost instant. Now, does it stay, right? So it actually stays very much. It's not short term, it's long term, and it's robust. What does it mean in practice is that as we have a blue on this graph, as we have a blue area, and we on top of that we have a special offer system which increases that baseline revenue, it increases in a long-term manner and in a robust manner. So after we put on top of that seasonal offers or live ops that has actually new content, it creates like this kind of spikes. But that robust part, the red part, is always very much long-term. Okay, so why changing data science, special offer system based on the data science techniques works? Why does it work? Does it actually make sense? Okay, so general special offer systems, they are not really effective during the progression. So their effectivity changes, it varies, right? So as the player progresses through the progression through the levels, basically the effectivity of system that is used normally starts to be sometimes high, sometimes low. And through data science, we can actually understand this automatically and optimize the supply in the points where the demand during the progression is not met of the supplies. Okay, so data science type of special offers systems can really adapt to players' demand, which changes based on the preferences and different game journey, of course. So that's why it works in general, because we create the better supply for the actual demand in the game. Okay, so let's look at how to build impactful data science solution based on our experience. There are three cornerstones. One is acquiring the right data. What does it mean to have the right data? Right data, from our standpoint of view, is to show the data that shows supply inefficiencies. So as the current system does their job, we need to understand where the supply and demand is not like matched. This is the right data. I'm going to talk about it a little bit more. What about the models? So we need to have a proactive and we need to have a reactive models. Reactive models are basically to learn or taught from the data. So because they react from the data. Now, in terms of proactive models, these are very more interesting. And I haven't seen many of the solutions like that, like to combine proactive, which is basically understanding player's journey and reacting and predicting what can happen, and combine this with the proactive and reactive modeling. So, and the last part is basically automatization. Because this kind of system creates a lot of offers, we need to have full automatization, which means that we need to take graphical assets of the game and we need to automatically, based on templates, create offers. Okay. In terms of data science, basically, right data means understanding the segments through segmentation of player base. In terms of modeling, pricing, and content, we have a probability, we have expert modeling, and machine learning models. And in terms of automatic offer delivery system, it is something that automatically delivers the offers, but also monitor the performance and gathers the feedback from players. And of course, feedback from players is very, very important. One feedback is, of course, the data. You can understand that, okay, you have this kind of show rate, you have this kind of like a conversion, RPU, but also community go through the discussions, understand what is the feel of these new offers, right? So there are two type of feedbacks that this kind of system can gather. Okay, so what does it mean to acquire the right data? So let's see this situation. We have a one player, okay? We have a day before yesterday, we have a yesterday, we have a today first session of the player, and a today second session of the player. Now the player day before yesterday basically could play some game modes, he could spend on some currencies, he could deplete some currencies, he could use some characters or some vehicles, something like that, right? And we can basically understand it from the data. Yesterday he could buy a new character, he could maybe use some sort of the items that he has in his balance. But what about the day? We don't know that, right? We don't have the data, but we can predict whether the player is going to actually get the new game mode, because based on his progression through the levels, he's probably going to hit today the new game mode, which actually alters his demand, right? New game mode should have some sort of new currencies, new characters maybe, and so on. So we can alter his preference. Okay. Well, the second session maybe joins the guild, joins the team. It also can reflect in difference of his demand. So this is proactive and reactive modeling. So in terms of reaction, we can understand from data, we can react with short-term, medium-term, and long-term preferences. In terms of proaction, we have to understand what is most likely to happen on the next sessions and put it to the model. And this is the right data that we are trying to find, right? One is based on a progression during the gameplay. One is basically data that we got. Okay, so very practically, it looks like that. You have to create player profile. What we created, we call it player profile, which basically is consisting of this kind of information which is necessary to understand his preference, short-term, long-term, and to understand what could happen on the next session. So, for example, in terms of purchasing behavior, there could be percentage of revenue per type of purchase. It can be conversion per type. It can be anything else, basically. What you think is important to understand for the player. In terms of items usage, what is mostly used item? What is last purchase item? And so on. So there is so many things that can be understood. And what basically limits us is only what type of model we can use and what is our understanding what are the relationship between what he does, what is preferring, and what he could buy or what he want to buy or want to look for buying. Okay, so let's look at optimizing player monetization experience. What player sees is this. He sees the offer, right? It's everything what he sees. He doesn't see anything else. It's just that. So we need to optimize every aspect of that. So what type of resources, what is the amount of resources, what type of chest, what is the price point, what is the discount, what is the availability? Should we put it 1 hour or 5 hours or 24 hours or 1 week? What is the visual? And actually this can be done, it can be optimized based on what I was talking about, the player journey and what type of data we can actually get. Optimization idea is to increase revenue per user, but without increasing the discount, okay? So for that to happen, we need to optimize price point, content, value, availability, and what is the sequence of offers. So what is the first offer, what is the second offer, what is the third offer in 3 days or in 3 weeks, whatever. And of course the visual, how it looks like. We found out that actually visual is very, very important. And the value, of course, is in personalization. So how to minimize additional value and increase revenue? It means that you just have better offerings in general. To create the better offerings, there needs to be optimization of different parameters to data. In practical terms, we are focusing on conversion RPPU, and combination of this uplift for the RPPU and conversion, this basically reflects to RPU, what we are looking for. So for example, we can have stable conversion. So we create the model, right? Create data science model, and we see that it doesn't improve the conversion, but actually improve the RPPU. What does it mean in practice? Is that actually it found the segments of players and gave them the pricing that is the most relevant for them without harming the conversion. So basically absolute well. So that is one of the examples, but in general, it reflects in RPU. This is practical point, and actually it can be changed. You can even have better data science solution which increases RPU with lower conversion and higher RPPU, and it can be different. It can be higher conversion, lower RPPU. So there is really a different variation, but in general, it reflects how the model is built. But what about the rest of monetization? What is the negative aspect of this? Okay, so the cannibalization is what we call is the effect when this kind of system, they increase RPPU, so revenue gain in general, but they of course decrease a little bit from either other EAPs that were already in the game. But overall, it is really, really positive effect. So the RPU is higher. So the game has better monetization. But maybe it's not as effective. So a little bit of it decreases the hard currency sales or other offers that were in the game and so on. So in general, as we look at RPU, we can see what is the general impact, but we also can check through different in-apps in a game. What was the effect of this new system to the other in-apps? And we can understand it and we can manage it. So what is data science wave of player experience optimization? What we want to do, what we are striving for to optimize this, we want to maximize revenue per every offer impression. So without increasing the number of impressions, we want to maximize the revenue from it. We need to create the create profile on a daily basis. So it has, of course, the data that I was already talk about. It is basically automatic daily preparation of data. We create first pricing. So based on a long-term preference, short-term preference, medium preference, there is that pricing that is created. Good way is that there is no proactivity in that. It's just reactive. So the pricing is from the data, okay? If there is no data, we can drive something from the segments or distribution. Second is offer content. So what type of chess, what type of characters, vehicles, and so on we should put there. In this case, there is a proactive modeling and reactive modeling. It's really important to have also proactive, because if you are only reactive modeling only from the data, the past data, you really cannot actually understand the full picture, why the demand changes. Last thing is discount strategy. Most of the time we actually hold this stable, so we are not really changing the discount in a way that we are not having like a different discount with the same offer. That's not what we are doing at all. So what we are doing is decreasing the discount, overall discount, every discount through every offer. We are decreasing it, and this is like a strategy, but there can be like a model that improves in that. And of course, the last thing is putting all of this together. At the end, model just gives you data about the player. So you can imagine that that player should get this pricing, with this content, with this discount, with this visual, and so on. We need to take this information and create basically offers from it to the game, right? Send it to the client and create the offers the player interacts with. And because this is daily process and this full automatization, we can actually create more than 20,000 unique offers. Of course, it depends on how many segments you have, and some of these offers are not going to be great, so we are going to put it aside. Some of them even you will create even more offers if you need. It depends really on how the complex the game is. I would say 20,000 is somewhere from the simulation to RPG. So what about the modeling? We have three types of models. Expert modeling, which you can actually imagine there is like a rule-based modeling. If then, okay, very simple. Probabilistic modeling is what is the probability basically that something happens from the data that we have for that player. Is not probability on like an overall player base. It's for that player always. And the machine learning, which is the highest like level of modeling, and this is basically train the model that from the data can find different patterns based on the segments and learn from it, and then basically optimize on that. In terms of like, imagine that we have a game with the potential of 30%. So 30% is from the audit. We play the game, we understand what are the sync steps and so on. So in terms of game design, we need to understand basically everything to actually understand what is the potential of them. So for example, we have a game with the 30% uplift potential RPU. So for the expert modeling, it is around 5 to 10% that we can actually uplift from the 30% because of the like way it works, and it doesn't reflect like all the segments and so on. And it's really simple in general, but transparency is very high and maintenance cost is very low. In terms of probability, it's like a 15 to 20%. Now transparency really is lower, but it's still workable. So we still see what actually happens inside the model. And maintenance is very, very low because basically probability you can do in SQL, for example. And the machine learning models, these are high maintenance models. Transparency is very low, but the uplift that can be generated is that potential. Okay, so this is in general how we are doing it in practice. We always start with the probabilistic modeling, but for some of you with a lot of experience, I would assume to go or suggest to go with the expert modeling. So we start with the probabilistic, and then we move to the machine learning because of the transparency. Okay, so on the left side, we have expert model. In the middle, we have a probability modeling. On the right side, we have a wide and deep neural network. So like this could be like a natural state for starting from the expert modeling, really understand every segment, then going to the probability modeling, getting a little bit more uplift, and then going to the machine learning. This could be 1 year project basically to really get that uplift. And this is just recap how it could work. So I'm putting it all together. So what we are basically striving to do is create for each of the segments on the right side, basically different offers. You can imagine there are 20,000 of these offers. How we can do it is that we know we have basically the data, the model already told us that, okay, based on preferences, long-term and short-term, it looks like it would be great if we recommend some like this offer to the player. Okay, so we need to actually from the data create automatically through the templates. Okay, automatically offers which are basically backgrounds, right? Benefits of this is as we use the templates and as we have a great artist in our team, we basically can really play with it. And this basically is hard to see that they are automatically created, really hard, right? And 20,000 offers of unique offers is in general impossible to do. Now there is a question of QA, but we are going to touch on that also. So we know what we want to do. We want to have for each of the segment different basically offer that actually makes sense and that increases RPU without negative things, meaning like a spamming of offers, higher discounts at all. They're not going to be these things. So we start with the data, player data, and we have a graphical assets. We have a modeling that I was talking about, and these are basic, almost always like 2+ models. One for the pricing, one for the content at least. It's hard to combine them together, pricing and content. It's always like a pricing optimization and content optimization. So we have already some decision maker. In this case, it is personalization engine. Okay. Personalization engine creates the table based on which we can take the graphical assets and automatically create offers from them and distribute these offers automatically to players. Okay, so this is done on the daily basis. This can be done on a 4-hour basis. It depends on, of course, on the style of the game, genre, and so on. Some of the games are okay with going with the batch personalization predictive, so once daily. Some of them need like every hour. It really depends on how strong and how long term or short term is the demand for things. Okay. If the demand changes very fast from one thing of currency to other thing to third thing and so on, then we need to have like way more and faster and frequent predictions. If for some games, even weekly predictions are okay because the preference of the player is long term or medium term. Okay, so in terms of monitoring, of course, this is something that basically after that, what we have is that we push the offers to the players, and now we can gather the data, right? We need to monitor it through like 3 things. One is monitoring the community. So this is like a feel of the community, how they react, how they work with it, right? Many times we decrease average discount from, for example, 50% to 20% of all offers. How they react is like different things, right? And then we can really use this 50% discount for really seasonal things. So we need to sometimes like put it to the state that is actually long-term, more profitable and sustainable. Monitoring preference over time. This is your usual analytics reporting and of course exploration of data, understanding what the effects, what the relationship between different KPIs, right? If something changes, how this reacts, this is A/B testing, all of that. And of course, monitoring cannibalization. In general, cannibalization always spikes from the start, but also RPU spikes from the start and then stabilize it. As you get the stabilization, you can basically see the trend. If it goes a little bit up, a little bit down, and then you drive down, you go down, deep down to different in-apps, and basically what you can see is how effective of these in-apps are. Okay, so you basically can see how effective are syncs and taps. So even through the cannibalization, what we found out, we can understand in a way better the economy of the game, and we can actually tell the developers many times that there should be better syncs for that, should be better maybe taps for that. Okay, so there's also like this passive effect of this kind of data science solutions. And of course, continuous improvement is the way to go. In general, almost always you see like huge uplift from the start, but then you see stabilization. But because there is no every idea in that system from the start, you can really play with it. You can really, in a risk-averse manner, you can try different things, if you are basically data scientists that really understand how to effectively A/B test. For some of the games that have a lot of players, can be weekly A/B testing cycle, which is in general crazy, because to get to the point of even higher uplift than 30-40%, it is possible if the ideas, hypotheses are tested frequently. From these tests, basically many times we understand the things that we didn't know from the start, and we understand the player base in a different way, sometimes in a different light. Okay, so what are the challenges and learnings? Like I mentioned before, many times we decrease the discount because these offers are just something that is more interesting. So we don't have to drive sales through discount at all, and we are not doing that. So that is something that is in general challenge, because a community perception is something that getting from 50 to 45 discount percent is okay, or 50 to 20, maybe some challenging. So there needs to be like an adaptation in that way. But of course, we are pushing the boundaries in this way. Sometimes data tracking for some of the games that we work with is just not enough. So we need to really improve data tracking, because many times, for example, offer impressions are not properly tracked. Offer impressions, so whether the player sees that offer, is really important. Is the feedback. Is the feedback from the player. So if he sees this and he clicks on it, and how he reacts from it, that's really, really important. We can basically understand and improve modeling on. In general, number of players significantly can improve the A/B testing cycle. So minimize the A/B testing cycle, frequency of A/B test, improve frequency of A/B test. Which means that if the game has not many players, the A/B tests are sometimes longer, and in ways this is challenging. Huge amount of content in the game and complexity. If the game is complex, this can create a lot of offers, and the QA, quality assurance of the offers, is challenging. So there needs to be, in general, very much automatic solution for a QA. And maintenance of some machine learning models can be really, really difficult in a way, because every external factor. So for example, every live can change some demand, can change something in the game, distribution of some KPIs of the players, which means that basically we need to retrain the model, and but of course the benefit of it is higher uplift in general. What are the learnings? This really works. This really works. We did it several times for different games, different genres, and we've seen great results. But we found out that many times basically the developers are a little bit scared of how players are going to react. Well, we found out that there is no impact on retention or churn. Okay, we haven't seen this anywhere, and I think this is really, really important to say. Uplift of this kind of data science models is really driven by minimizing the gap between demand of the players and supply of offers. Which means that if you have, like right now, the greatest system of special offers in the world, you're probably not going to get the uplift. But many times we've seen that that is not the case. Okay, so we cannot change the demand. What we can change is really supply. And because the supply is not optimized in a way for the demand, this is what actually drives the uplift of data science solutions in this case. So cannibalization can be easily understood and managed in a way, because as we see it through different in-apps, we can understand that probably some things doesn't work at all. So we can actually, in a content offering for that system, we can actually minimize the content, which basically decrease the cannibalization for that in-app. And impact of pricing and content, this is something that is really additive. Okay, so if there is a model for pricing, if we create a model for content, it's just way better together, okay, than just one or other. And the pricing in general has the highest uplift possible. So starting with the pricing, then going to the content, I would suggest. And we tried a lot of stuff. Our creative team is really great with it. They tried a lot of different like visualization teams for the offers, and they really done a great job. And what we found out, I was not expecting that, is that really to the game to get to the 3D special offer background, they actually increased the revenue by 30%, which is in general crazy. And so even create visuals have the very high potential to play with it and see the results. And of course, everything can be A/B tested. Everything can be done in a risk-averse manner. Trying with 2% of plays, 1% of plays, even less, again, and scaling up over time through the whole player base. If you would like to do that with this kind of special offer data science solution. And this is everything from my side. Thank you very much.
Thank you very much, Robert. So thank you for a great speech. 1 second. Okay. And now we will go to our questions. Okay. Is your ML model creating personal offers in live as a part of a server code?
No, it's not. Basically on the side, because this is not on the server. This is a separate solution, which means that it's basically run on the cloud, and there is a really high, I would say, consumption of resources. So this is really something that is on the side, and what basically is sent to the game is just information, necessary information. So, for example, created already pictures and configs. That's it. So it's not part of the service side on the cloud.
Thank you. Have you compared ML offer system with a similar conventional system created by a game designer with relevant content? How do you understand that your offer system is better than any other?
Okay, so that's a great question. So what we are doing is always, I wanted to get to that. What we are doing is really always A/B testing. Okay, so we always have a control group, which is basically here. Okay, so we always have a control group. That control group basically uses the old system, and we have a variant group which uses this new system, so we can easily understand the uplift. Okay, so these kind of uplifts, what I showed here for the expert models, probabilistic models, and machine learning models, capture uplift down here is basically the uplift that is compared to what the old system is doing. Okay, so we always everything that we do in A/B testing. So we always compare control group with the old system and variant group with the new system. And even the variant group we split and we create our A/B testing of our system, okay, new system. So which means that you can have 50% old system, 50% new system, and that 50% of new system you split, and you can use different variants of your new system. So we can do this kind of A/B testing, and this basically tells you exactly how good are you, and how whether it's short-term uplift or long-term uplift. And for some of the projects, we have like this kind of A/B test when we run like a 95% to 5% or 90% to 10% of control. Okay, so 10% control, 90% variant for like 2 years. Okay, so because we always can see the uplift through comparing these two groups. And of course, just one thing, of course, there is a random selection which is done on the side of the customer always. We are not really creating by ourselves, so that's why we can easily compare.
Thank you. Our last question in the row: how many in-game content is needed to generate such tremendous amount of offers, 20K per day?
Okay, so about up to 10 types of currencies, 5 types of gacha, for example. You can have like, I don't know, 50 characters. So there is basically a combination of all of it. And I probably forgot about something, boosters. And so, yeah, so they're basically as I said, as the game is more complex, it has many characters, many type of chests, many type of currencies, hard currencies, soft currencies, characters, buildings, whatever. And basically the combination of all of it creates this kind of like a crazy amount of number of offers.
Maybe you have additional questions in chat? No, only in Q&A. Okay. Thank you very much, Robert, for such a good lecture.